Now, finding right triangle trig ratios works with three basic trig functions. There are 6 total, but we're just getting into the beginning. Sine, cosine, and tangent. And we work with a right triangle where we identify one of the non-right angles as theta, and that's just a Greek letter. It's a 0 with a kind of squiggle line in the middle. And we have the hypotenuse is always the side across from the right angle. It's always the longest side in the right triangle. The adjacent side is the side that is with the hypotenuse making angle theta, and the opposite side is the side across from angle theta. It's not actually one of the two sides of the triangle making the angle. And we work with so, and that means sine is the relationship. If I take sine of the angle, I will get the relationship between the opposite side over the hypotenuse. I will get that ratio. Cosine is adjacent over hypotenuse, and tangent, TOA, is opposite over adjacent. Okay, you want to know that because that's how we set up these problems all the time. So we can also undo it. That means we take the ratio, the fraction, and get the angle. And to do that, we do sine inverse of opposite over hypotenuse will get us the angle. Cosine inverse of the adjacent over the hypotenuse will get us the angle. Tangent inverse of opposite over the adjacent side will get us the angle. Example 1, given the triangle below, what are the values of the following? Sine of P. Well, I see P. Sine is opposite over hypotenuse. The opposite is 12. The hypotenuse is 37. Okay. Cosine is adjacent over hypotenuse, so that would be 35 over 37. And tangent would be opposite, which is 12, over the adjacent, which is 35. Example 2, given the triangle in example 1, what are the values of the following angles? I want to know angle R and angle P. Well, I can do angle P first, or angle R, doesn't matter. Sine inverse of opposite over hypotenuse would be the measure of angle R, and opposite of R would be 35, and hypotenuse would be 37. So we would be doing 35 over 37. Put that in the calculator, make sure we're in degree mode, and we get 71 degrees. Sine inverse of opposite over hypotenuse for measure of angle P, well, that's going to be 12 over 37. And that gets us 19 degrees. And let's just double check. Let's see, 71 plus 19, 80, 90, that's 90, plus 90 is 180. All three angles add up to 180. We're good. Example 3, given the triangle below, what is the length of the indicated side rounded to 1 decimal place? So we want to know x, that's adjacent to the 51 degrees, and we've got the hypotenuse. Y is opposite of 51 degrees. So working with SOHCAHTOA, x would be cosine of the angle equals adjacent over hypotenuse, so 51 degrees, x and 12. And to get x by itself, we would just multiply both sides by 12. So if I type in 12 cosine of 51 in my calculator, I should get the answer, which happens to be 7.6 if I round. Y would be sine of theta equals opposite over hypotenuse. Fill in 51 degrees. Y and 12. Again, multiply both sides by 12. And so 12 times the sine of 51 would be y. That happens to be 9.3. Example 4, given the triangle below and A equals 5, B equals 12, C equals 13, what are the values of the following sine of A? Well, sine of A would be A over C, which is 5 over 13. Cosine would be 12 over 13, and tangent would be 5 over 12. Sine of B, that would be 12 over 13. Cosine of B would be 5 over 13, and tangent would be 12 over 5. Notice the relationship if we're working with two angles inside the same right triangle. Sine and cosine flip, as in sine of A is the cosine of B. Cosine of A is the sine of B. Example 5, a moving boat is observed from the top of a 150-foot high cliff moving away from the cliff. The angle of depression of the boat changes from 45 degrees to 14 degrees in 2 minutes. Find the speed of the boat to the nearest foot per second. This is the type of problem that you would end up using it. This is kind of a real world setup. So we got two triangles. We've got the first one where the angle of depression is 45, so the angle that we want would be 90 minus 45, which is 45, 150 foot tall, and we get x. That's how far from the cliff the boat would be. Then we got the longer one, which is still 150 foot tall. We got that distance y, and then the angle is going to be 90 minus 14, which is 76. So working with tangent here because we don't have the hypotenuse in either case. So tangent of 45 equals x over 150. And tangent of 76 equals y over 150. So x is 150 times tangent of 45. Y is 150 times tangent of 76. X is 150. Y is 602. And I'd like to know the distance between them because that would tell me how far the boat has traveled. So total distances traveled is 452 feet. Okay. Now, distance equals rate times time. We have our distance and we have our time. We don't have our rate, and that's what we're looking for. And so d divided by t, distance divided by time, would equal our rate. Now, we were told the time in minutes, but we want to know foot per second. We already got feet, so we could change that 2 minutes into 120 seconds. Already to do the conversion, plug it in, and solve. I'm just going to work with the 2 minutes. 452 divided by 2, that gets us 226 feet per minute. As I said, that's a bit of a problem. I don't want feet per minute, I want feet per second. So I take 226 feet per minute and multiply it by 1 minute over 60 seconds. Because that's the conversion factor to turn minutes into seconds. Minutes cancel. And 226 divided by 60, that gets me about 4 feet per second. And then you've got your practice 1, practice 2, and practice 3.